Right, good evening. Welcome to the University of Westminster and G4C's Data in Construction event. Just like to get a quick thank you in immediately to the University of Westminster for hosting us in this really good space, so thank you for that. I'm Will Waller, and I'm a G4C board member, and I'm leading the data work stream in terms of what we do. And Antonio will cover a little bit more of what we do later on. So why are we doing an event about data in construction? I think it won't have escaped anyone in this room that we're in a period of rapid change and an increased digitisation of everything. And effectively we're seeing masses of data come to the fore. And in the last 2 years alone, 90% of the world's data has been created. And actually, compared to individuals in 1986, we as people now receive 5 times as much information every day. So there's a lot of data out there, and many would say that we're on the brink of a revolution in terms of that data and what you can do with it. And so that's what this event here is all about. But what does it all mean? And I think that's really what we need to get to the bottom of as an industry, and we need to understand how we can seize the opportunity in front of us, and the potential prize is huge. And on the cut there are just some of the benefits that have been cited by other industries that are already a little further ahead in terms of data than construction, but also those that have already started looking at the subject and writing about it. So without further ado, I'd like to invite our first speaker to the stage, Professor Jennifer White from the University of Reading. That's me being filmed.
Thanks, Will. I titled the talk Digital Delivery, BIM and Big Data, and I'll just talk through those 3 topics over the next 20 minutes. Just a little bit about myself before I start. I'm a Professor of Innovation and Design at the University of Reading. And I lead a small exploration group there, a team of researchers in a centre that we call the Design Innovation Research Centre. And we've been looking at the way that digital technologies change design, and then also the links between design data and construction and operations over the last 5 years. There are basically 2 themes. The first theme I kind of grandly call science of design. We've been out looking at big projects. And the second theme kind of more about bringing some of that learning back into the university and playing with the next generation of technology and looking at new solutions for delivering. Let me use this. So why are we interested in digital delivery? A lot of the methods for delivering projects were developed in a world that looked like this. And yet, as you know, we're rapidly moving into a world that looks more like this. Yeah? In fact, we may be beyond this. Right? And so we started to think about how the delivery of projects needs to change given the changing tools that we've got at our disposal. All of the things that we know about project management, you come out of these sort of big projects like SAGE on the left-hand side, or this is NASA in the 1970s in the middle. And yet we're in this kind of much more interactive world where project management could look quite different, where the delivery of buildings, the delivery of infrastructure can look quite different. What does that mean for us? Yeah, and I don't have all the answers to that. You guys, as the new generation, are part of constructing those answers. But I think that problematic is there. Yeah, we started to think a little bit about, what new kinds of project management might there be. And I did some work with Ray Levitt at Stanford University in the US. And he has this sort of argument around moving from a project management 1.0 which is all about management as tracking and eliminating variance from plans, to a much more agile world of monitoring, integrating, analysing information on real-time and predicted performance. When I go out and I look at big projects, I see both of those things. Yeah, it's not that everybody's thrown away their kind of schedules or their kind of long-term plans, but I think those things are hybridized. There's what IBM calls data at rest and data in motion. Yeah, there's sort of still big integrated data sets, but then there's this massive churn of information and information streaming in and out as we're constructing projects. And my kind of second topic of building information modelling, I guess, is part of that. Yeah, I'm sure it won't have escaped people's notice in this room that there is a massive government initiative around developing information sets, building information sets, and using them in operations of buildings. So the government is driving this as a client. They're not driving it as a regulator. They're saying, if you want to work with us, then you need to be able to engage with this world of information. And they have a diagram that many people will have seen, yeah, which is about this kind of step change in the way that they see it from BIM level 0, which is kind of CAD or drawings, lines, arcs, sort of paper-based kind of methods, to a world of file-based collaboration, to what they want to get to, this kind of level 2 BIM, which is around file-based collaboration and sort of library management, which is their aim to get the whole industry to that level by 2016. And then the kind of long-term aim from that perspective is around these kind of integrated interoperable data sets. And integrated web services, BIM hub, etc., etc. And I've been in some of the debates around level 3, and I can tell you that the life cycle element of that is seen as being extremely important. So it says life cycle management on that piece around level 3. And I think this is not just about data in the project, as we've traditionally thought of project delivery. This is about seeing construction in a different way, and seeing the information about buildings as being an important deliverable out of projects. So projects deliver not just buildings or infrastructure, but they also deliver the information that goes with that. And clients can make decisions about their portfolio of property or of bits of urban infrastructure in ways that allow them to think about capital and operational expenditure together. So we no longer start to see projects as being these kind of islands, but they're part of clients' investment strategies. And I think this integrated interoperable data then starts to bring it starts to reconfigure bits of the industry. It starts to make people rethink what their roles are in the industry. And people have to start to think about their role, both in terms of delivering projects and also in terms of the longer term use of them. As one of the academics involved in project management has said, the bad old days are over. The kind of build it and disappear days are over. Yeah, this is about kind of seeing buildings and infrastructure as being kind of much more of a long-term thing. And so, of course, given my research interests, given the things that we do, I also teach about building information modelling in the university. And I talk about it as being about coordinated asset information and about structured processes for sharing information through life. And so we're really talking about information and quite structured processes for sharing information. Sort of on the left-hand side, there's the model, but then also kind of information about the model. And on the right-hand side, there's a sort of British standard process for sharing information. These ideas are really not new. Yeah, they're not new. And this is from a paper that I wrote 14 years ago now. And it's not that different from the kind of ideas that are currently being implemented around how you might integrate and share data. I think we have opportunities. I think there are opportunities in implementing this in terms of level 2, but we also have opportunities to think beyond this. The technologies allow us to think about more agile ways of working, and so I want to encourage you to see the benefit of this, but also not to limit your thinking there, but also to think beyond what we might do with, what other ways might we configure the industry to work with data. I mean, it's exciting for me to work with students on the course, and they do a range of really exciting and interesting stuff. It's a 1-week module, and within a week they develop really a lot of work collaborating across disciplines to do a range of different roles using the model. And those structured processes for using data are very much about how do we collaborate across the industry? How do we create collaborative project teams where people can understand their role but also work with people from other roles in a collaborative rather than an antagonistic way? And models can be a good basis for doing that. And actually many of the people I teach are not designers, they're not architects. They're people who use the model in the roles that they have in the industry, whether that's quantity surveying, whether that's looking at sustainability of the output, whether that's construction management and scheduling. So I have a range of MSc students from different courses that come together to work on the project. And in my research, I've mainly been looking at big infrastructure projects. So I just want to say that for me, although we talk about building information modelling, this applies equally to infrastructure. Yeah, I sit on the Institution of Civil Engineers Information Systems panel, and they're always kind of trying to remind people that when we talk about building information modelling, these things apply to infrastructure too. And I think as we begin to think about smart cities and so on, then the crossovers between buildings and infrastructure become kind of relevant and useful to think about. Although I've got an architecture background, I ended up looking at big projects because in a way they're where some of the problems of managing big data sets get written large. Yeah, and I'll come on to some examples of that towards the end of the talk. And we've been thinking in the university then about how do you visualize big data sets. You've got all of this data, you've got all of these people working with the data. How do you visualize that? And back in the 1990s, when I did my PhD, I did work on virtual reality, and it went out of fashion for a number of years. And I have to say, the idea of visualizing has really become salient again, has become important again, because we start to have so much data. Then the questions about how do you visualize that, how do you walk through it, how do you engage with it become important. And we've had a number of underground stations and other big projects come out to Reading and use the immersive visualization facility that we have there, which the cave, this is Bond Street, and the people out there looking at their model in their cave. A cave has got 3 walls and a floor, and a number of you can walk inside and wear kind of stereo glasses and experience it together. And it's different from other forms of VR in that you can experience the same thing together, and that has some value. And we've actually been doing some research developing a mobile version of that so that we can take out and put up very quickly. So we have a version that weighs about 75 kilograms and that can be put up by a couple of people in less than an hour, and then people can start to display the models and to walk through them. So I want to then come on to the analytics. I think I've talked a bit about sort of BIM, and BIM is very structured data. When people are talking about big data, and I've been engaged in some of the debates we've been having in Reading about big data, people are often talking about a massive amount of data with both structured and unstructured data. So large it's difficult to process using standard database and processing techniques. Or they're talking about the kind of 5 V's, if you like, volume, velocity, variety, value, and veracity. And I think this kind of idea of velocity streams of data is part of what I'm hearing when I'm engaged in people talking about big data in the university. People are talking about generating large data sets and then having to do analytics on the fly as data comes in. They're talking about having massive data sets. And I've been thinking about how that relates to some of the things that we've been looking at in construction. It clearly relates to other areas in construction, such as the work that's going on sensors, where you can get data streams off sensors that are embedded into buildings, or off meters in people's houses, smart meters, smart cities, smart infrastructure. And I think our work kind of dovetails into that. But the bit that we've been looking at has been really on the data sets that people are using in delivery and then to hand over to the client to use in operations and maintenance. And we've started to think about how we might analyse those data sets in different ways. And this is work that's being done by a PhD student in my team, Guoyang Guo, looking at using social network analysis to analyse how different actors are interacting with each other as they're putting together contract documents. And so she's analysing the interaction between actors and the interaction between documents and actors. And what's novel about the work that we're doing in Reading in this area is that we're using data directly from an extranet to do this analysis. So people have done social network analysis in construction, but they've tended to do that using interviews. So they've gone out and they've interviewed people and they've asked them who they interact with. We're not capturing every interaction, but we are capturing all of the interactions that are going on in the digital system. And so we can analyse people's behaviours in this digital world and how their interactions, ideally we'll be able to say something about how their interactions affect project outcomes. This is the aim of her work. As I realise we're being recorded, I'm showing you some of her early work, and we've gone on and done work on a number of other projects. But let me show you how this plays out over time on a project. So this is a sort of static snapshot of the interactions. She's also, in which she's identifying a core set of actors in the actor network and the document actor network. She's also done work on a kind of dynamic social network analysis. And here, if I can just set that going, on this diagram there's a sort of delivery team and the client, and in this sort of first phase you can see there's this kind of early interaction with the document controller and the client through the extranet and the interactions in the extranet. There's a range of interactions in the delivery team through that. And actually perhaps not as many as you would expect. And that would suggest that it's not being used for all their interactions, but people are uploading stuff periodically. So there's this kind of second phase of information exchange amongst a delivery team, and that kind of varies in intensity. And then right towards the end of the project, as it just plays through, there's some feedback to the client, or there's a kind of stage gate where information gets pushed out to the client. And what's interesting about analysing the network over time is it starts to allow you to say things about the process of interactions up to stage gates. Yeah, so again, the interactions are all in the delivery team, and then sort of approvals and handover through the document controller to the client. Yeah, and then there's kind of questions that you can ask of that sort of data set, right? When do you need information to go out to everybody? Yeah, is that kind of copy all a productive behaviour, or is it not productive behaviour? And we can start to analyse these data sets and start to understand what's leading to good outcomes through the use of these sorts of tools. The other area that we've been thinking quite hard about is how you manage change in very large data sets. And you may say that this is all Project 1.0 kind of techniques, and I would agree with you. These are very much techniques about how do you manage change against a baseline. But we're observing people really using this kind of change control in very, very big projects. And we've been doing some work on change control configuration management within Crossrail, which is this big railway project through London. I think you'll probably have seen some hoardings for it if you walk around the streets. And we brought them and Airbus and CERN together to look at how you manage very, very big data sets. And if you think that Crossrail has a lot of data, then some of these other contexts outside construction actually manage a lot more. So Crossrail, 2 to 3 million asset records, 1 million model and drawing records, sort of 250,000 records in GIS. But in CERN, the Large Hadron Collider, up to 100 million configuration items that they're managing. And this starts to be the sort of scale of data where you can't just correct stuff manually. You start to have to automate processes and think about how you're going to manage data differently. And so we were looking at why people were implementing change control and how they were doing that. And this is work that has really been led by an NGD student in the team, Angelos Stasis, and working with myself and Carmel Lindquist, looking at how tracking status of assets, recording the origin of materials, linking to manufacturer information, version and change control. And I think, as we start to develop these data sets, then we can start to develop understanding of things like sustainability that we don't have at the moment because we just don't have that information available. And so there's a lot of reasons behind why the government's interested in getting people onto this track of thinking about BIM and more data around construction. So I'm going to finish with some sort of questions, I guess, for the audience. Around analytics for next generation construction, and I know some of the latest speakers have some ideas on this topic, around the kind of boundaries of formal systems and the social interaction technologies that we all use and love, about how we join agility, open innovation, low transaction costs, and this kind of world of engineering data, quality control, long-term thinking about how we have this kind of stable data and reuse data. I think this data in motion, this kind of very quick kind of data of LinkedIn updates or what have you, versus this kind of more stable data where, if we're building certainly infrastructure, but also buildings, they last a long time. Yeah, so they may still be there in 100 years. How do we make sure that we have the data that we need for 20, 30, 40, 100 years in the future? And, you know, that will involve us being a bit more sophisticated about, you know, which data is just, you know, kind of the LinkedIn update that we need for a day or two. Yeah, which data is important and do we need to manage in a serious way for kind of long-term use? Thank you.
So my name's Chris Gage. And I lead our cost intelligence service line at Turner & Townsend. Today I'm speaking on my own behalf though, so views expressed are purely mine. Maybe a couple of slightly controversial ones in here. So yeah, what I want to do today is really just kind of talk a bit about where I see the future going in terms of construction, particularly around professional services. Talk a little bit about some of the buzzwords out there, you know, the likes of big data, which Jennifer's already kind of touched on, the Internet of Things, and also data visualization. So that's really what I got in store. So first of all, if you to read The Economist, I think probably everyone from about middle that way would be human beings, and then in 20 years' time this is, and all you lot would be redundant, okay? So that's what you might believe if you read The Economist. Now, kind of distorted, in fact, probably that's where those guys are. This has already happened. This is, the future's come already. There's actually a study by Carl Benedict Frey and Michael Osborne at the University of Oxford, and what they were saying was that 47% of job categories are at high risk of being automated at some point in the near future. In particular, white-collar type roles, the likes you and I are involved in. So I think it's important. I think we need to be aware of where things are going and just kind of anticipate, and be at the forefront of it rather than kind of trying to anticipate, rather than trying to react to it. In terms of where I think things might change over, if we were to fast forward, say, 20 years, where do you think things might change? I actually think that some of the real mechanical task-based roles, we may see these disappear either completely or be radically different in 20 years' time. So things like contract administration, cost management, estimating. If we can use the data out there, to automate some of these processes, then we're going to see big efficiencies in the management of construction projects. There'll be ones that probably do survive, so more on the strategic side. These are more complex and creative roles. Design, you've got to start somewhere, and it's, there's certain kind of human faculties that you cannot replace with computers. Also the people side, things like commercial management, maybe project management as well. I see those surviving in some kind of form. And there'll be completely new roles as well. So people who can automate processes, programmers, data scientists, these sorts of people who can create management assurance systems. Everything's automated, and of course artificial intelligence and things like machine learning that Rob Symes up after me hopefully can talk a little bit more about. That's where I see it going. Might be wrong, but I think the point is just need to be aware of change and make the best of it. Already just wanted to spend a couple of moments just talk a little bit about my background and kind of where I've come from and why I think this is going to be the case, and it's not just because the economists say so. And basically, there are two real kind of experiences in my early career which kind of sent me down this route. So I started off in financial services, came to construction quite late on actually, and one of the first jobs I did was to work in pensions. We used to create things, we used to operate private pensions for likes of the big four, wealthy individuals, and what it enabled them to do is actually kind of invest their own investments where they wanted to. Now we used to create statements of accounts, cash balances, things like this, and just to give you an indication of how kind of backward it was. If someone wanted to understand how much cash they got in the portfolio so they could make an investment, they'd phone us up. We didn't give them the result there and then. We had to go back, get the information from all these different systems, put it into Excel and calculate it. We said we'd do it within the same day. When you compare that to the way the world is now, you go online and you get your information instantly. And the way I kind of responded to that, and we also measured on like how quickly we could turn things around and how many errors we got. I was a bit error prone at the time, got a bit frustrated with it, so I really started getting into like automating processes and systems, and using data to take out my own sort of fallibility as a human being and try and automate these things. The second one was actually another job a bit later on, working for a financial advisor network, and there's lots of sort of sales information coming through. So we operated sort of sales on behalf of our network partners. And we had all this data flowing through the business. This was back in about 2007. And we decided to sell that information. And I can't tell you how much it was we sold it for, but the numbers were quite staggering given the fact that we were just hitting a download button and taking that information out and sending it to the likes of big project financial services providers, likes of Norwich Union, those kind of guys. And that really kind of woke me up to the power of data. And so really the rest of my career, I went into construction, but it was really very much of a data emphasis. Loyalty cards. So are loyalty cards really about customer loyalty? The answer is no. It's really, resale organisations gather huge amounts of information about sales to customers. So what's been bought, when, how much. That's not good enough really to really understand your customers. So what they do is they offer you a club card or a Next card. You fill in loads of information about yourself, demographic information, your income, your age, this kind of stuff. And by fusing those two different data sets together, they can really understand purchasing behaviour and drive their retail strategies on that basis. So again, that's how in resale they're using data to really power their business. And I think this is really how far all the different sectors are progressing at the moment. So we know about the likes of Google, other IT companies who really build their entire business around data and the use of data. Retail just spoke about their financial services a bit further back. But I think, if we're being honest, construction at the moment is probably towards the back of that queue. But some might say is the greatest opportunities to really benefit from data once we harness it. And the fact is, it is more difficult. What we're trying to do is turn the physical world into the digital world. And that's much easier than, say, financial services where transaction really starts and ends its life as an electronic transaction. So how can we use data to drive action? I think this is a really good graphic, actually, that Gartner, a research firm, have produced. And it really, you start on the left there, you've got your data, and then you've got your action on the right-hand side. And you've got basically analytics and human input going to the decision, then the action. Now, we've got 4 levels there of kind of maturity, I guess, in the use of data to drive actions. So the first being descriptive, what's happened. So in our industry, it might be maintenance costs are too high. So then if we drill down a little bit further and try and diagnose why, so we may see that certain assets are failing too much. So we've understood the cause of the problem. But what about if we can actually predict when these things are going to happen and preempt them? So if we're talking about asset maintenance, if you wait for an asset to fail, it's very expensive to then go and fix that asset. Because if you've got, say, a broken sewer pipe, customers aren't going to be too happy about waiting around for someone to come and fix it as their garden fills up with all kinds of nice stuff. On the other side of it, if you're spending loads of money preemptively on assets that aren't going to fail, that's also a waste of money. So what you're trying to do is find that sweet spot in the middle. And predictive analytics is the way forward. And again, this is Rob's area. I'm sure he'll talk about it a bit later on. But you can use techniques like machine learning to really understand your assets, look at previous historical data to identify when those assets failed, and then use that to extrapolate forward, and then you can put that maintenance in just before it fails and get absolute massive efficiency from it. And the final step there is prescriptive. So what should you actually do about it? Using the same example, it may be that you've got some kind of dashboard which tells you which asset's going to fail. You send a team out, so that would be decision support. It may be that actually you automate that decision completely, and automatically send out an order to your maintenance teams to go out and fix or carry out that maintenance work. There's always risks with decision automation. I mean, we've seen it in financial services, so you've got automated trading, and first flash crash back in the 80s. We've seen a couple of other examples since. So there's always risks trusting important things to machines, but it works well as well. You just got to manage those risks. So what I want to do now is really just touch on a few of the buzzwords and themes out there, and just try and link them back to our industry. So the Internet of Things, big data, and data visualization. So if we start off with the Internet of Things, and this is really all about sensors and how you connect different sensors. I mean, I've got my mobile here. It's got GPS. It's got Wi-Fi. It's got NFC. It's got all kinds of sensors in there. And we're starting to see all these devices becoming a lot more linked. And I think probably if you look at the top right-hand box there, this kind of brings it home to where we are, sort of energy. So you've probably heard of Google acquiring a company called Nest, and that means you've got internet connected thermostats, which means you can regulate energy through your mobile phone, or just more intelligently through algorithms. And it's really how you kind of link up all those different sources to manage things better. We've heard of the internet fridge, which is a bit of a ridiculous idea when you first hear it. You think of an iPad stuck on the front of a fridge, and looking through your web pages there. But actually, if you go beyond that, and you're not just kind of surfing the internet, and you're using it to work out how often do I go into the fridge? If I'm away at work all day, I'm not going to go into the fridge, so therefore I don't need to spend loads of energy, getting the refrigeration unit going. It could just maintain the current temperature. So we can use this data to drive much better efficiency. And it's becoming really real now. So you might have seen this in the news. David Cameron's going to pump £45 million into the Internet of Things. On Monday, there's an article in the FT about London City Airport, and they're starting to connect up everything there, so that you arrive at your gateway and you've got a cup of coffee waiting for you. I'm sure there's more useful applications for it as well. But it's happening now, and maybe this is a bit of a better use case here. So the smart grid. So how can we connect up power stations with homes through smart meters? And use all those different sensors to really optimize how we manage our energy and make sure we're not wasting it. Using the wind farms as well to make the most of that energy when it's available, and then supplementing it with more reliable sources such as power stations. So that's the Internet of Things, and that's going to create huge amounts of data, and to be able to run those systems effectively, you're going to produce big data, and Jennifer's already kind of talked about it. Quite a nice little infographic about it there. If you look at the top box, we've got total petabytes being stored across each of those regions there, so 3,500 petabytes. I'll explain what a petabyte is in a minute if you don't already know. But things like, if you look at the bottom there, velocity, one of the V's you mentioned, 2.9 million emails sent every second. 20 hours of YouTube video, we're contributing to that at the moment, I believe, being uploaded every minute. 50 million tweets a day. So the amount of information that's being produced now is phenomenal. And if you look at the box below, actually, you can see the different sectors there. We've actually got air transportation, construction, quite high up in terms of sectors that can really benefit from this sort of stuff. So what is a petabyte? So that's it there. It's a huge number of zeros there. So we've got the world's effective capacity to explain information through a two-way telecommunication network. So what this is doing, this is trying to say how much information was there in existence back in 1986. We're saying 281 petabytes compared to 2007, 65,000. So the increase in information being produced at the moment is just phenomenal. Google processed 24 petabytes of data per day in 2009. It's incredible figures there. Human brain, 2.5 petabytes. I think that's quite a lot, actually. I think Jennifer's probably 3 or 4. So that's big data. Now, what I want to do now is just kind of bring it back down to earth a little bit, because I don't think we're on top of small data yet. Yeah, I think forgetting about the big data, we need to look at this first. So, just a couple of kind of use cases of analytics, I guess. So, what about procurement? So, if we imagine we track actual costs much better in the supply chain, we can start building up a picture, maybe a bit like this, of different activities and what the outturn cost is. We could draw a line through that, so you've got kind of typical normal distribution. Now we might say that our current price at the moment under the rate schedule is £5,000 to carry out that rate. Maybe that distribution indicates that we could do it at 4,800. So maybe we can use actual cost data, like detailed data, to procure more effectively. Also, what about choosing the right form of contract? So you can see again normal distributions there. You can see the kurtosis, which is the width of that distribution. Now, if you've got a really nice, narrow, tight distribution, then you can be very certain about what the outturn cost is going to be. If you've got a much more distributed distribution, wider kurtosis, maybe you need to look at sort of cost plus forms of contract. Maybe you need to break it down into 2 different rates rather than 1. So there's other ways we can use analytics to be a bit smarter about how we commercially manage projects. And what about funding? So we're probably all aware of the difficulties that we have funding infrastructure. And I think the reason is because it's very difficult for investors to really understand what the risks are around investments, and also construction investments tend to be very illiquid, long term. So why can't we package all these projects together, chop them into the different activities that can constitute those projects, and then build financial instruments that match the risk profile against them and the certainty of outturn cost that you get around those. And so you might be able to set something up where you've got debt finance for very certain outturn cost activities, whereas the more difficult ones to predict, you might finance that with equity. And it just gives your investors different kind of risk profiles to go for. Some investors want high risk because they want return. So there was a few ideas about how we can use analytics. I just wanted to spend a bit of time now on data visualization. So I've got a couple of examples here. So I'll just jump out of the presentation there. This isn't construction related, but I thought this is a great bit of data visualization here. So what Bloomberg have done is they've taken data about all the top billionaires in the world and put it into a nice interactive infographic. So you can see Bill Gates there, 78 billion net worth there. A few others, I don't know if you recognise these guys. Warren Buffett is a famous investor. And you can filter and play around with it. So we could look at females there. There's quite a few in the top billionaires. Sources of wealth, inherited or self-made. But it's self-made. Not such a good picture there. But we can look at different age groups. So the youngsters. I'm sure Rob's going to be in this list before too long. Yeah, it's just a great way that you can interact and play around with data online. Now, we do a bit of this in the infrastructure sector ourselves. It's a bit difficult to show you information that's our client's data, so obviously we can't release that. But what I can show you is just some analysis we did on some open data. And what this is showing here is this is passenger numbers across the network rail network. What we've done is we've taken that information and represented it geographically. So every one of these bubbles represents a station around the UK. We can see the big ones in London and the smaller ones outside. You can see the actual routes there. Now, the green and red, the green indicates a growth on the previous year, red indicates decline. So we can see how this changed over time. So there's quite a bit of increase around London at the moment. If we go back, interconnect connection is a bit slow. If we went back to 2008, you can really start seeing when at the time of the financial crisis, you can really start seeing that there's quite big outflows of people or traffic, if you like, from around London. We could also zoom in, see what London's actually like in a bit more detail. It kind of gives you an idea of the scale of the data we've got behind this. I wouldn't say it's big data, it's all structured, but it's quite a sizable data set nonetheless. We can look at particular stations as well. So look at that, London Waterloo, 96 million passengers last year. It's the top one out of all of them. It's an incredible number of passengers. We can filter by a particular region. So we look at the east. Cambridge is top in the eastern region. Anyone want to shout out a station, their local station? Don't be shy.
Aberystwyth.
You got a long commute.
I don't know. It's a good name, isn't it?
So we can actually focus in on a particular station. So Aberystwyth, quite a small one, but it's great. It's doubled. It's doubled since 1997. So massive growth there. We've just got a bit of a chart here, just showing the comparison of London to the rest of the UK in terms of passenger numbers. You see, it's quite steady, around 50%. So London is absolutely massive in terms of commuters, as I guess you'd kind of expect. We've also got a bit of a graphic there around facility owners as well. So just a couple of examples there around data visualization. I think that kind of brings me to the end of my discussion. I just really wanted to get the message across that really we should all be out there anticipating, driving change rather than reacting and resisting to it. So that's what I'd say. Next up is Rob Symes is a true East End Silicon Roundabout data rock star.
So yeah, my name's Rob, and that was a very nice introduction by Chris. But I run a predictive analytics company. So we're based in Shoreditch, so we're part of this whole digital data revolution that hopefully is going to be storming your industry. But I don't actually know a huge amount about the construction industry, so just a disclaimer there. But I've been working a little bit with Chris, and he's been telling me some of the things that you've been doing or thinking about doing. So what I'm going to do is talk a bit about sort of how we got here, a bit about our experience. We do a lot of work with the property sector, so our customers, people like Knight Frank, Carter Jonas, a lot of others. We don't do a huge amount of work in construction, but we work across insurance, financial services, recruitment, lots of industries. So our whole sort of bag is we're trying to bring predictive analytics or data science to business. So I've got a team of 10 data scientists at our Silicon Roundabout office, and we're sort of recruiting another 15 to 20 this year. So we're actually going to try and recruit pretty much everyone who's coming out of UCL. I was actually asking Jennifer if I could take any of her staff. She doesn't want to give me any just yet. But the idea is that we're trying to bring data and data science to industries that traditionally would not use this kind of thinking. So it's quite interesting to be networking with a bunch of you guys. So what's our story or my story? So I graduated in 2008, so it's a fantastic time to graduate. No one would give me a job. I did try and get a job at one of the smart professional services firms, and they offered me a job and then turned me down. So I ended up working. Yeah, exactly. Now I can get over that. So I ended up working at a recruitment company. So has anyone come across Manpower, the very big recruitment business? Yep. So I did that, hated it for 6 months, and then ended up working out how to be quite successful at it. And then I co-founded a recruitment business called Campbell Black. So Campbell Black was, and it's interesting you were talking about smart grids, because we recruited into the wireless sector. So our whole business was recruiting technologists and data scientists and sales directors into places like O2, Telefonica, B-Sky-B, all those kind of clients. But one of the biggest frustrations for me was that we would spend a huge amount of time trying to understand who was going to be successful in a business. So let's say we were recruiting a sales director for B-Sky-B. So we'd interview them, we'd do psychometrics, we'd do every kind of test we could do, but actually it was very, very difficult to predict who was going to be successful and who was going to be a failure. And this happened over and over again. So we'd place someone into a massive organization and they'd be a huge success. We'd place someone into a similar organization, they'd be a huge failure. And we had no understanding of why that was. So, and what I sort of came to realize over about 24 months of research was that business has been focusing on the wrong things. So I got on a plane, so I went to basically all over the world. So we went over to New York, we went to San Francisco, and met every academic who's been interesting in terms of data science in the last 40 years. So we spent a lot of time with Daniel Kahneman, who's won a Nobel Prize around how you mitigate bias using data. We met Cade Massey at Wharton, we met a bunch of people at Yale. We spent a lot of time at the Stanford Institute and their AI team as well. So we met Carol Dweck. And we also met, so how many people have come across the book or the film with Brad Pitt called Moneyball? Anyone? Okay, good. Right, so we met a bunch of people in the baseball industry. So we met a former NASA engineer called Sig Mejdal, who is using predictive analytics to predict which baseball players they should actually pick and which baseball players they shouldn't. Traditionally, you wouldn't expect a NASA engineer to go and want to work for a baseball team because he can get paid a lot more where he was, but he absolutely desperately wanted to work in baseball, and he had the kind of skills that some of my data science team have in Shoreditch. So that's a great example of bringing science into a new kind of business area. So we did that, and then we made a whole documentary about that. So the documentary was basically me as an entrepreneur kind of saying, right, we think this is a problem. Does anyone else think there is, or is it just me kind of on my own, right? So I'll show you the trailer, if this works, hopefully, briefly, and then I'll start talking a little bit about predictive analytics and machine learning, if it works.
How do you measure if they have those qualities you were talking about?
Yeah, you don't measure, you smell it, you sniff it.
There is just massive evidence that it is not to let humans make the final decision.
But do you think that these types of human behaviors are as integrated in business as they are in baseball?
If they can get it wrong in baseball, we have challenges elsewhere.
There's a clear gap between what science knows and what business does, and I'm travelling halfway around the world to see how big that gap is.
Okay, so can I click on from that now? No. I might need you again. Sorry. So that was the film we made, and obviously you saw Kahneman talking about it. So has anyone come across his book, Thinking Fast and Slow? Very good, a few of you. So he's a very interesting guy. He's been doing this. So a lot of the stuff that we're trying to implement isn't very new, right? So we all know that human beings are biased, and generally, thank you very much. We're not fantastic at making our own decisions. So one of the things that actually Chris was talking about was something about prediction in terms of costing, wasn't it? Yeah. So one of the biggest things that we see is that people are generally very overconfident in their ability to do things. So, and that's why I think a lot of the reason is the construction industry generally overruns and overcosts projects, because we've got an innate bias that means that we think we can accomplish more things than we can do. That doesn't mean we can't accomplish great things, it just means that when we're trying to plan something, we need to understand data and humans. So we need to have an outside view, which is why our company's called the outside view, and an inside view, so people who understand project delivery, all that kind of stuff. So we have this phrase in business, data is oil, data is the new oil. So it's basically all about that you will have huge amounts of data, and Jennifer talked a little bit about this, in your businesses that you will not be using productively. So, and the reason is, in the same way that the sort of oil rush happened in the 18th century, 19th century, you needed the right tools to get them out. And you need actually the right people to do this. So generally, businesses like financial services have been recruiting huge amounts of very statistically minded people for many, many years. Generally, a lot of other industries haven't been. So that's something we're addressing. So we have a phrase in our business, we are what we measure, why not measure what we want to become? So our business actually focuses more around the person, so it focuses more around people. So a lot of the products we're building about how you can unlock the potential of people within your businesses. A good example of that is making a salesperson more efficient, making a forecaster more efficient in their forecasting. So these are what we would call the 3 phases of big data. So the first is collection. So you're all doing that all the time. So Chris and Jennifer were talking about smartphones. You're all collecting data, walking around and collecting huge data all the time. Problem with that is you're not using any of it, really. It's just completely pointless. What a lot of businesses are trying to do is understand things. So what Chris was trying to do is show you a visualization or a dashboard that tells you what's happening in commuting patterns in London. So that's great, and it looks quite pretty, but it's not prediction. And you need to make a very clear distinction between what visualization is and what prediction is. So if someone shows you a pretty dashboard, ask them, is it predictive, or are you just showing me something pretty? Okay? So, and this is where sort of our business focuses on, right? So most businesses are about here. We sort of say, you know, this is where repeatable elite performance happens. How many of you do know what machine learning is? Okay. Can I have a definition at the back there? No? Okay. No? All right. We'll talk about it later. So this is how our system works, right? So we have what we would call a suite of algorithms, a suite of machine learning algorithms that I'll explain to you in a second. And we have a suite of where we collect data from. So I'll talk about the property industry to start off with, so because it's something you may understand more. So we take data from structured data. We take data from places like the Land Registry or Experian or any other public data sources, and we take data, what we would call unstructured data. So an unstructured data set would be something you can't put in a table straight away. So it would be something like email or phone or online data that's harder to quantify, right? And there are 3 things we're trying to do with the property industry. The first is we're trying to predict with more certainty which deals are going to close in their pipeline. So if you look at a normal property company like a Knight Frank, a Carter Jonas or Savills, all those kind of people, they have huge amounts of houses that they're trying to sell on a regular basis. So we tell them which houses are going to sell and which houses aren't going to sell. And the reason for that is it's interesting because they spend a huge amount of time trying to sell houses that are almost impossible to sell. So there's a huge lack of efficiency. The second thing that we do is what we call elite performance. So going back to my original sales director example, there are salespeople who are great and salespeople who are crap. Obviously no crap people are here, but they do exist apparently. But we tell people how to statistically improve the probability of selling. Right, so we give them real-time information based on email, based on phone calls. Just to give you a bit of example, so we have a voice analytics solution that, let's say me and Chris are having a wonderful phone call. It will transcribe that in real time, put it into a database, connect up to our predictive cloud, and push it down to tell him, am I more likely to sell to Chris or not to sell to Chris? Right, so it's quite technically advanced. So we can talk about that later if you want to. So that's elite performance. And then we do a thing called predictive lead scoring. So one of the biggest inefficiencies in any business is marketing. So you spend huge amounts of time trying to win business, but actually you don't know who to sell to. So a normal salesperson will have a list of potential customers, whereas a data scientist will give you a list of people who are actually ready to buy. which is a really big distinction. It's very, very different. So we take data from the land registry, proprietary data from some of our property clients, mash that together and give them a list of people who are more likely to sell a house in this financial year. So they spend their time then marketing to those kind of people. A lot of this stuff was pioneered with the Obama 2012 campaign. So if some of you have come across that, they used huge amounts of data to predict which people were most likely to be persuaded by Barack Obama. So all this stuff is all possible, and I don't know quite how it relates to your industry, but it's potentially quite interesting. So machine learning, I'm going to explain a little bit for you. So when you were a baby, try to think back to that time, if it's okay, you didn't know that the person on the left was a girl and the person on the right was a boy. Obviously you do now. So you actually had to learn that, right? But the biggest problem is that a computer doesn't understand, intuitively like you guys do, that this person is a girl and this person is a man. So you have to teach the machine, it has to learn what is a girl and what is a boy, right? So, and the way we do that is a thing called feature extraction. So we will take out the features of the girl. So if you look at the feature extraction a little bit down there, we take out the features, so the hair, the top, the height, all those kind of things. We take that out and label them as features. And once you understand what a feature is, then you can try and sort of reverse engineer what it means to be a girl and what it means to be a boy, right? And if you do that enough times, the computer can then begin to understand on new information what is a girl and what is a boy. Now clearly, maybe that's not that interesting for you guys, but conceptually, it's very, very important, because it's the same. That's called the classification problem. You're trying to classify gender, boy, girl, right? So why it's interesting is it can solve any question that's binary. For example, will a house be sold or not sold? Will this project overrun or not overrun, right? It's a classification problem. So this is just an example of how you would teach a machine how to understand if it's a girl or a boy, and then it would be able to predict. If it saw a new photo of a girl, then it would be able to predict what a girl was. So it's quite interesting, and that's basically that's a good example of what machine learning is. You would teach a computer how to do that. So here are some facts. So these are some examples from some of the companies we've been working in recently. So it takes about 25 weeks to sell a house, and it takes about 20 weeks to not sell a house, right? It's the same effort. They put in a huge amount of effort into every single house. They try and put in a huge amount of effort into selling anything that they get on board, especially in London, as there's a supply in stock, right? A shortage in stock. But they only sell about 50% of the houses. So they think all opportunities are equal, but actually they're not at all. All opportunities are not equal. Some opportunities are much easier to sell, some opportunities are not so easy to sell. So our prediction, basically, and this is for a number of property customers, so we can predict after 1 week's worth of activity whether a house will sell or not sell. So it basically saves them about 19 weeks worth of effort, which is quite good, hopefully. This is quite interesting in terms of Chris's question. So how do you predict revenue? So one of the big things that property companies do is they all go and sit in a room for a long period of time and try and predict what their end of year bonus is going to be. So if you're Savills, you're hoping for £1 million if you're a partner, basically. So they go and sit in the room for 2 weeks and try and predict things. Actually, it's a completely inefficient process, because a computer can do that far better than a human can. The reason, because you can't look through every single Excel spreadsheet that's ever existed, and a computer can do it in the blink of an eye. So what we've done there is, if you see the purple line is our, and this is not their data, just so you know, we've kind of jiggery-pokery, but the principle's the same. The purple line is our prediction on what their end of year revenue is going to be. The green line is their actual run rate, so what they came up to. And if you can sort of see, I won't bother pointing, but if you can see about 6 months in advance, we can pretty much tell what their end of year revenue is going to be. So if you look at, an example like a Knight Frank or Savills, you have hundreds of negotiators going through this time-intensive process. They now no longer have to do that because we do it for them. So that's just one example. So the elite performance stuff is what I was telling you about earlier. So this is just pretty shit visualization, actually. But if you look at it, so the bubbles represent opportunities. So a big bubble has got a high probability of selling a house. A small bubble has a low probability of selling a house. Red means it's going to sell very quickly. Blue means it's going to sell very slowly, right? So the question is, where does a negotiator or where does a salesperson spend their time? So they obviously spend their time on the places where they can make most money. And we also tell them how to statistically, it's obviously dummy data, we tell them how to statistically make more sales. So for example, we'd be able to tell them that if you phoned Chris Gage at 3 p.m. on a Thursday, he's more likely to pick up the phone. We'd be able to tell them that if you sent an email with this kind of phrasing, they're more likely to buy a house from you. Those kind of things. So this is more construction related, maybe. So Chris and I have been talking a little bit about projects. So if you're doing a huge project at, let's say, Scottish Power or something like that, and you're trying to put up a bunch of pylons or you're trying to put up any fixed build thing, right? The problem is that the data never gets back to the original company for a week, 2 weeks on how the project is actually running. It's quite difficult to update that kind of stuff. So we've had a little bit of an idea based on this thing called MealSnap. Now MealSnap, for some of the men and maybe some of the ladies as well, is an app that you can take a photo of your food and it will automatically tell you the amount of calories that it has. So if you're going down to Burger King, it's not a good thing, and if you're eating very well, then it will tell you. Now the reason this is interesting is because it's using a machine learning algorithm that has taken billions of pictures of food, and it's trying to predict what kind of food you've taken the photo of, and therefore what amount of calories it has, right? And the idea is obviously over time you can tell how many calories you're taking, and then if you want to lose weight, that's great. But the clever bit is the photo, the machine learning, and then pushing it back into a calorie count. So I was kind of amazed that, and maybe this already exists in the construction industry, but we're building something around this. So I don't understand why everyone carries a mobile phone, why people couldn't take a photo of it, a photo of various points in construction that, so you can take a photo of a pylon that's in mid-development, let's say for example, and you could teach a machine that that's in mid-development, right? Once the machine knows it's in mid-development, it automatically talks to the cloud, it automatically tells the client, and you understand where you are in the project. So, and then, as you go through the stages, you understand if it's running late, running, on time, behind budget, all those kind of things. So it's actually quite simple to do. All the technology exists. We're building it for one of the property companies for something else at the moment. I'd be interested to know what you guys think. And if this already exists, you can tell me shut up. That's absolutely fine. But it just seems an obvious thing to do very quickly with machine learning and the technology that already exists. It's not virtual reality, although that sounds great with the Iron Man stuff. But it's quite something quite simple. So so that's me. I know I've gone quite fast. But I hope you sort of understood a little bit more about what machine learning does, and obviously I'll be around for questions later. Thank you.
Thanks, Rob, and thanks to all our speakers. We're now going to enter into Q&A and kind of discussion. So I would really encourage everybody to ask as many questions as possible. I think there was a hell of a lot of extremely interesting stuff there that could have a massive impact on our industry. So if we're okay to get started for the panel, if you wouldn't mind taking your seats. And if you have a question, please just raise your hand. And fire away. Antonio.
Just to get started, really interesting how you predict the outcome of a process. I understand that the efficiency of your predicting outcome procedure is based on the availability of data. I know it sounds quite stupid, but is that right? We have a problem with that. As an industry, we struggle finding data and sharing data. Or, we're pretty silos-minded. How other industry go around it?
How do other industries get, God, that's loud. How do other industries get around what exactly? So the sharing of data?
Availability of data, increasing the number, the quality of data, and sharing it if possible.
Yeah, so sharing it's always going to be hard with competitive stuff, right? So what I would say is a little bit of data science goes a hell of a long way. So you don't need to try and start using something like voice analytics straight away, because it's just really, really difficult to understand how to get the data. So to your point, so how would you solve those kind of questions? So there's a huge amount of data in businesses. So, you know, someone like Turner & Townsend has a huge amount of proprietary data that they would own, so they don't need to share that with anyone. I know there seems to be a lot of open data, so you do need to go kind of through a clean process, like cleaning that data and then getting it for use. But what I think is where you have the biggest opportunity is when in fusing proprietary data and sort of open data and putting that together to build predictions. So there's no way around the fact that data has problems and it's difficult to access it. It's just a lot of hard yards and getting it into a structured format that you could actually do it well. And as an industry, you'd have to actually think about what you'd want to accomplish with that.
I think to add to that, actually, the biggest challenge I think for our industry is we've got a big thriving supply chain. So, you know, if you take like a London Underground or a Network Rail, they don't do the work themselves. They contract it all out to the supply chain. Now, the suppliers, you know, and they contract it out, and you've got many layers of suppliers, and they're all operating as very commercial organisations in their own right. So sharing information is a real challenge in that respect. Now, I think contracts like NEC, open book contracts, you know, they're enabling more information to be shared. So I think that's a really good way of capturing the loss of that data and sharing it between supplier and client. And that's really where, you know, our kind of, that's where we've come back really, because we've been looking at cost plus contracts, gathering all that data together, then analysing and using that exhaust data for analytics and trying to provide new insights into, you know, clients' construction projects.
Did you want to add anything to that, Jennifer?
I mean, I just wanted to add that I think this is changing, because if you look at the government BIM agenda, for example, that's about the clients saying we don't just want a building, we want the building plus the data that goes with that. And so, you know, the client, the owners and operators of the built environment are requiring the data, and they want to own it alongside the physical infrastructure. And so then there starts to be opportunities for them to aggregate data, for the government to start to understand portfolios that it owns, and for us to start to think about these kind of analytics.
Yeah.
Without sort of breaching confidentiality or anything like that, but in relation to Turner & Townsend, you know, how big is your team, say, 2 years ago to now? And, you know, strategically, you know, how is your team positioned? Where do you see it changing and developing going forward? And outside of your team, some of the things that are being discussed, how, you know, from a commercial aspect, do you see that, again, changing particular touch points, key touch points within a global business like you work for?
So, I mean, I joined Turner & Townsend 3 years ago to set up the team. We're now up to around 20 people, just over, sort of across the UK. So it's growing pretty rapidly. But if you compared that to the likes of, say, IBM, you know, and they've just got an organisation to create this artificial intelligence sort of system called Watson, is it? Yeah, Watson. They're using 2,000 people in that organisation, so the scale of it is just phenomenal. But yeah, we start from a small area, but you know, we're growing the team quite rapidly, and yeah, it's big excitement for the challenges ahead, I think.
And is it a strategic imperative for the global business or just the UK business?
Data's probably one of the biggest topics at the moment for our company, I'd say. It's right up there, you know, and you see it everywhere now. People are talking about data, big data. You know, it's really kind of getting that airtime now in the boardroom, I'd say. So
final question, I apologise. So in relation to that, sort of back to my original question, in terms of your slide about sort of certain roles and what roles are going to be born and things like that, again, in terms of sort of key roles, everyday roles, if you like, within the construction industry, TNT, etc. Do you see the skill sets changing in terms of what you're doing and particular areas of the business? I know you deal with infrastructure and property. Do you see sort of new skill sets in sort of core areas?
Yeah, I think I think all the skills we got now will stay there. I think, although I was being a little bit provocative, I guess, with that slide, I think those skill sets will still remain. I think the job roles will be slightly different. There'll be a different balance. So I think we'll see a lot more analytically orientated people coming in. So we're recruiting at the moment accountant background type people, people who are good with numbers. We're looking at starting to bring in maybe some data scientists as well. And I think you'll start seeing those sorts of people who can program and can create data visualizations and predictive analytics. You'll see all those skills going throughout the construction industry, I think.
Thank you. Any more questions?
I'd also add to that, actually. I think that if your firm wasn't looking at data, like they are, they would be absolute idiots. Because, the thing is that there's so much automation that's possible. That's what I think, and I'm really interested to learn from everyone else because I don't know very much about the construction industry. But when we were just talking for half an hour, there are so many opportunities within that to automate, to improve, to start predicting things that you never thought possible. And until you get the smartest people working on the toughest problems, you don't actually know what's possible and give them the data sets. So I think that's really good.
I think it's quite a big open-ended question, but we've talked about what improvements can be made. What in your mind would be the biggest advantages that would occur from using BIM and big data and Internet of Things in the industry? Biggest wins?
I think the biggest win, if we can achieve it, is around collaborative working. And that requires us to use technologies that do the bits that people can't do well. And I think at the moment sometimes we've got a lot of technology, but we're still requiring people to do things that machines do better. Yeah, and so I think collaborative working is a big win. Some of this stuff that my colleagues on the panel are talking about around automating is a big win. And I was in Heathrow Terminal 5 10 years ago, and they had a single model environment there. And there was a lot of discussion about, is it possible for people to really work like this? Can they automate stuff? And that was a pioneering project in the UK in terms of using this sort of technology. And I can tell you that things have moved on rapidly since then. So all of those people who said we can't automate, we can't do this. Yeah, well, actually, we have done. Yeah, and I can imagine a similar kind of step change over the next 10 years.
Yeah, I'd say probably three things for me would be efficiency through automation. It would be predictability, and really those two things will make infrastructure and construction generally much more palatable investments. I think we'll see finance improved a lot through the financing of projects improved a lot through the use of data. They're the three things for me.
Yeah, perhaps collaboration's a means to an end, and these are the kinds of ends. Yeah.
I think the collaboration piece is really interesting. I thought your network diagram was great because. I think Jennifer's right. I think machines have a great ability to understand things that we currently aren't able to. So if you're looking at how to collaborate well with a client, generally a lot of it will be done over email or over phone. Or face to face. We're not using Google Glass yet, but don't worry about that. But with email and phone calls, you've got a huge amount of data that's actually being captured, and you can actually track if a project's on track much more efficiently than having someone actually log it. Because people don't like to be logging, they like to be doing things. So getting people to interact with a system like Salesforce or like a CRM, it's really invasive and really difficult, and you actually, as a human, you don't really want to be doing it. So if there are ways to capture that data without me having to input stuff, that's really, really valuable, I think.
Any more questions from the floor? Yes, sir.
I deal with on a marketing level, so digital marketing, so looking at analytics from using websites and understanding how search engines are being used. I'm trying to kind of understand when, we use analytics and data to help shape websites and how people interact with websites, and I'm trying to kind of understand it from a building perspective. When it comes to websites, and you can kind of say, right, okay, well, certain people are doing this, certain people are doing that, certain people behave in this way, and you can make these changes and you can act in real time. When it comes to buildings, you can't kind of look at data and then go, I'm thinking after the life, when the building's been built, and probably facilities management companies looking at how people engage and interact in buildings. You can't then turn around and go, actually, data tells us that we should have done it like this, because then by the time you've understood that data of how people interact, just thinking of that train station example, how people go in and out of train stations. What's your views on kind of how far can we go in terms of using this data and saying, well, okay, well, the line kind of draws here where data can't really act on it quick enough? If you see where I'm coming from, at some point I'm just trying to think where the limitations are. Where
the line is quite near at the moment, just because we don't have enough data to do it. I think that line just extends and extends the further you go and the more techniques you develop. I mean, be able to recognise, number of calories from a plate of food. I mean, that just, even now it sounds a bit crazy to me, but 10 years ago that'd just be ridiculous, wouldn't it? So. Yeah, I think there's big challenges at the moment, but all the other industries are struggling with data quality. It's not just construction industry.
So your question was more around like where's the limitation of data, right? So we always say like the past is prologue. So you can't. Prediction is not a exact science. It's probability. So a great book to read is by Dan Ariely, which is called Predictably Irrational. So I think that generally if you're looking at human behavior, which is your website thing, and build environments is the same thing, you're trying to look at what people will do. Generally, humans, we all like to think of ourselves as mavericks and one-offs and good-looking and fantastic, but actually we're quite predictable. So if you look at enough patterns and enough historical data, you can build fantastic predictive models. That, again, a little bit of data science goes a long way. So, I know Jennifer was talking about virtual reality and planning how you do you build something. I think that's a fantastic example of how you can use data and maybe look at historical models of what's worked in the past and what hasn't worked, and then try and predict out in the future. So obviously it's not going to answer all your questions, and it is all probability and it's all uncertainty based, but it's certainly a step forward.
I guess we're kind of just really early at the stages of collecting data, and like I think it was in your slide we said in 20 years time I'll probably be 58 by then, so the fun will only begin.
But I think certainly to address the sustainability issues that we have, and the built environment, has a big impact on the sustainability of society, right? Then we need that data, and we need to think about design of new build in a different way. But a lot of the work that we're going to do, an increasing amount, is about maintenance, upgrade, repair of existing infrastructure. And so I think there is a massive amount of data out there that we can tap and that we can use right from the early stages of projects. There's really no excuse to start a project with a blank sheet of paper, and nobody does these days. But we can get more intelligent about how we start to think about building and maintaining assets in the built environment.
I think we had a question there. Yeah. Thank you.
Sorry, as a old white male, this all looks like advanced sub-optimization. We're just doing the same things over and over again, using machine, doing it more efficiently. Whereas, and the same with BIM. BIM as a technology just looks to me like doing what we should have been doing anyway, just doing it quicker and perhaps a bit better. Whereas, so I'm perhaps positing two ideas. One is this sort of sub-optimization, just using machines to do it. Surely big leaps only come by people doing things differently, and that requires often collaboration. And I don't mean sort of collaboration using BIM, that seems just like coordination, not collaboration. It's about surely developing a new way of doing things, changing by a step change, not just more and more iteration, more and more analysis of what exists now.
So is your point sort of that we've got these big words like big data and BIM and all these exciting new things, but actually all this stuff is just progressing gradually anyway?
I came from manufacturing and Six Sigma is really fashionable, but it's just doing the same old thing over and over again and just reducing variances. It's not doing things differently. That requires leadership, not management. And to me, a lot of this is just about operations and management, but we need to do things differently. That requires leadership and vision, not a machine.
I totally agree with that, actually. But I think the good thing about all these buzzwords is it does give a bit of airtime to people who are trying to develop things in that way. So the fact we're here today is because big data is the big topic and everyone's interested in it. If that word wasn't out there, people probably wouldn't be interested, would they?
I mean, I would agree that there is the potential for technology just to kind of continue to institutionalise old-fashioned ways of working. And so I think
spend more money on it.
So I think that but I think that it also provides opportunities to rethink how we do business. And so, this is kind of partly what we were thinking about when we were thinking about, the way that some of our approaches to project management come out of the 1950s and out of these, very large projects with very small windows onto data. And, I think that the new forms of data and some of the work on data and analytics provide new opportunities for thinking about how we configure construction that are actually very radical. And so, there are opportunities here to really rethink how we do business and think about it quite broadly. And I'm certainly not trying to advocate just sub-optimizing existing processes with more technology. I think that there are opportunities to think quite creatively, and I see people doing that, about how we use data to make the business different.
So I completely agree with you, right? So if predictive analytics or data science is all about just incrementalism, it's all about just kind of making revenue do better. I mean, no one cares really, right? So it's great and all that, but it's not a huge shift. So I've spent a bit of time in Silicon Valley recently, and they talk about people who, we don't have a poverty of brain power, we've actually got a poverty of ambition. We need people who are like Elon Musk. We need more people like Elon Musk who are going to build rockets that are going to send us to Mars, right? That's what we need. We don't need, predicting revenue is not in the same category. So let me give you an example. So we're doing, and it's not in the construction industry, we're doing a project with my company at the moment, which is around healthcare. So we track every single part of our life, right? So we track our health, we track our wealth, and we track our happiness. And we have a huge amount of sensors that do all that kind of stuff. And I'm going to commit to basically wearing a wearable device for the next 25 years, and the ability that hopefully it will predict me having a heart attack and the ability to live longer. And the reason that, maybe that sounds egotistical, because I do want to live longer, but the reason is actually if I can predict with more certainty when I'm going to have a heart attack, I can go and see a GP instead of going to A&E and spending £5,000 of their money every night. So that's a pretty cool thing if you're able to get people to live longer, to live to 150. And I think the only way to do it is by using data science and collaborating with doctors. So that's the kind of, you need a big idea. You need to try and solve something big. Because otherwise, if you're just trying to predict revenue, then, to be honest with you, no one gives a amount to that.
Thank you. Yeah.
Just on the Internet of Things in general. In terms of the Internet of Things and the government's investing 45 million, etc., is construction being thought about as part of that, or is it just every other sector?
I think this is a question for Chris, who brought up Internet of Things.
Sorry.
Maybe one of my slides. As far as I know, it's not specific to sectors. I think it's just big fun, but I actually don't know the details of what that 45 million is and how it'll be spent.
So a lot of it's being spent on things like thermometers in the home, and that kind of stuff. So there's a company called Alert Me that I think does a lot of work with British Gas that is all around trying to predict. It's trying to use data that can tell you, what temperature you want your house to be. So clearly that's not, good for them. That's great, but the Internet of Things is more around kind of the connected city, the connected car. So you'd be able to get into your car and connect, and you'd be able to sort of go around a city, and it would tell you. So Google's got an amazing thing that you can follow it around. Follows you around. Sorry, because you've got it in your pocket, and it can recommend you where to go, where's going to make you happy on a Saturday night.
Future cities.
Yeah.
Those sort of companies.
Yeah, they're a bit slow actually, but yeah.
A question at the back there. Thank you.
Thanks. Jennifer, you mentioned that you saw a lot of the future in letting machines do the things they do better than what people can do. In that respect, in construction at the moment, where are the areas that machines aren't doing things better, but that they would lend themselves to doing better?
Well, teaching BIM, I just think we still ask people to do a lot of, to follow procedure, and people aren't good at following procedure. So the more that we can automate some of that process-driven stuff, the better. And we take that off the individual. We sort of end up, we let computers follow procedure, and we let people make intelligent decisions with the data to hand. Yeah, if we can use machine learning techniques, that's great too. Yeah, but what I'm seeing in the classroom, and then also with the industry partners that we work with, is people being asked to do things that they're not good at because they're asked to follow procedure. Yeah, and people are not good at following procedure.
Okay. Yeah, and we have a question at the back there, please.
I just have to agree with what Jennifer just mentioned. This is more of a comment. I think the biggest thing to make any of this type of data sharing of information to work is to really, I do on-site construction recycling. We go on building sites with machinery, balers, what have you. And what I've noticed is there's a real disconnect from head office to what goes on into the guys in the muck, especially site managers. Now, you got a site manager who's got to follow, let's say, BREEAM report daily, health and safety report daily, consider constructors report daily, and at the end of the day, you're supposed to build something. I see these guys are now in the porta cabins more so than actually out in the field supervising what's being built. If it can be automated, such as a BREEAM report, and that would help definitely, but I also feel that the only way this is going to change is your brand, reverse it, start from the muck up, and get the guys who are building your brand in the field educated to what there could possibly be savings, waste, that type of thing. Or else it is not really going to work. And you're dealing with guys now in their 50s who've come up through the tools, who've been there for a long time. A lot of them have left now, but the younger guys are coming in. And that's the fundamental big change on site, is going to be the disconnect between head office and the guys in the field to make this all work.
Thank you. So we have one more question, and I think we'll start moving towards...
Can I make a comment on that? Because I think there is a really important thing that you're touching on there, and certainly in the way that technologies like BIM have been thought about to date, then they've often been thought about as something for the tier one and the client, right? And I think there's a really big challenge about how do we use technologies or to engage further down the supply chain, or should we think of the supply chain as hierarchical in that way? Should we start with the person on site and then think about how we're going to use how we're going to move the construction industry forward using current technologies and future technologies from the perspective of the people who are actually building the building, and what does that mean in terms of the technologies that we need in the different areas of construction for delivering the right thing to the client. So I think, as we start to think about how these technologies change the industry, we certainly shouldn't just be thinking about tier one. We should be thinking about the industry from the point of view of the people who are building the building.
Can I ask this question?
Of course, yeah.
Sorry, I thought it was a really good, interesting comment. So the guys actually on site, right? They're sort of 50s. They're clearly not, they're not playing around with every single social networking app that's ever been invented, right? But they all have a phone. I would have thought they will probably own a phone, and are they allowed it on site, or are they not? Is that? Yeah. So I'm just interested in that.
I think I know where you're going with this. I can't tell you the number of times that I've been asked to grind up 25 pallets of brand new material, just get rid of it, or landfill it. So often I thought, well, why not just take a picture of the waste? And you can also, as you said, identify different things such as plasterboard getting wet, so that's going to be a waste stream, automatically cover it up every Friday before the weekend. But I've tried so many times to say, can we not take that 25 pallets of new breeze block and use it on another build, especially house builders who have maybe, 25 different elements of a fabric of a house that they could possibly use on other sites. And it gets down to the logistics side of it. So let's say you take a picture, you say, I got 3 pallets of this. Does anybody else in the system or other site can use this material? Now we're talking logistics, handling equipment, yards to store it in London. So it gets down to almost the logistics stuff, but the amount of good material that I've had to recycle and shred is shocking. It truly is. And then the builder on their website said, we are 100% recycled because our material recycling facility, or Skip guy, says he recycles everything, which is not the case.
Yeah.
Okay, so I see there's a real need, but it's a matter of how can you implement that on a site level.
So it's not, I'm sure it's not as obvious as this, but it seems to me solvable, right? So you've got, let's say you're taking a photo of your 25 pallets that are going to be wasted, right? That's uploaded to the system. The system understands that there are 25 pallets there. So then that communicates to all the other people who are on sites about, do you want a pallet? So an automated message would go out to someone. It would hit someone's phone saying, do you want to reuse these pallets? Yes, no. Simple, right? If someone says yes, then automatically it's dispatched. Someone's dispatched to that site, has to go back, take the pallets, put it where that's actually needed. If it's not used, then maybe you can automatically put it on the open market to sell it or something like that. I think it's possible.
It's not materials, but Crossrail, for example, operates a system for equipment where they coordinate centrally so that when a particular project stops using certain item equipment, they make it available for someone else to take on, so you don't have to send it back to the supplier and then get it back out again. So it's not materials, but it's a similar kind of technology. It's not as advanced as the sort of thing you're talking about. It's really just a central log. But I think we should have the same thing for materials, definitely, if it's not happy already. Yeah.
Thank you. Okay, if we could just have one more question, if there is one. So, yep, Tom.
This might be a slightly controversial question given the nature of the event, but we're talking a lot about using technology and data to remove humans from doing process-driven stuff. We're then also saying that using predictive technology, we can get them not doing the judgment sort of side of things. So I'm talking about maybe 15, 20 years down the line while this technology is a lot more powerful, and you might be looking at 80% of this room are now redundant. Are there social implications to our incessant need to drive efficiency to make money for people who already have quite a lot?
It's good. It's a good question, actually. I think it is a concern. We saw the Luddites try and prevent the use of machinery during the Industrial Revolution. I think you got to worry about the social implications, but I think the idea is that enough other more interesting roles will be created to fill those people's availability. So it's a bit difficult to predict, but yeah, I recognise the concern.
I mean, I just think that we need to make better choices about the built environment that we build and operate. And so any tools that we can use to help us do that are really important. We've got a massive challenge in terms of making it sustainable. And that is a huge challenge. That's going to involve as much brain power as we can throw at it and all the technology we can possibly use to help us do that. And so for me, I'm not in that space of worrying that there isn't enough to do. I just think, we've got to make this built environment better. And to do that, we should use all of the tools at our disposal and see them as being, helpful to us to making a better built environment, because we need it. I mean, there is a burning platform here, right? The built environment just has to be more sustainable than it is. And the industry has to be able to work out how to deliver that and deliver it efficiently, effectively, and so on. And so, the tools are going to be useful in doing that.
I think, was it Keynes, I think, who predicted that by now we'd only have to work 3 days a week. Now, if you look at what they were used to in terms of possessions and all the rest of it, then you could probably work 3 days a week and achieve the same lifestyle. I think the trouble with human beings is they're always looking to compete and get ever more wealthy and all the rest of it. So I think there'll always be the drive for people to get more. It's just providing them with the jobs, I guess, to enable them to do that.
I think it's a really good question, right? And I'm probably the worst person to answer it because I'm trying to disrupt lots of things. I'm the sort of devil in the room. But yeah, I think, as these guys have said, I think you need to see technology isn't going to replace humans in lots of areas, right? So, in the construction industry, you're going to need judgment and architects and wonderful people to build sustainable houses, and you're going to need to understand how do you do that. So that's why we would sort of call that an inside view, so an inside person who understands the industry, and then you might need an outside view to supplement that kind of stuff. I think this argument about automation is kind of going to, it's inevitable. Some of it's going to happen, some jobs are going to get lost, but hopefully you'll be able to do more interesting jobs instead of doing the other jobs before, but I don't know.
Okay, thanks very much for your questions. I'd like to say a really big thank you to all of our speakers today, and I'd also like to add to that a really big thank you to the University of Westminster team as well for all their help putting this on. So if we can just show our appreciation, that would be much good. We're moments away from lovely beverages and things. There's just 2 more snippets that we're going to give the stage to. So Antonio, do you want to just say a couple of bits? Yeah.
Thanks again, Will. Thank you, guys. That was absolutely fantastic. I'm sorry to bother you again with this, but it was absolutely amazing. We're going to have another one soon. Let me just introduce myself. My name is Antonio Pisano. I'm the co-chair of G4C. Thank you for being here today and for being part, even for just one night, of our movement. We are a volunteering organisation of young professionals committed to improving our industry. The first G4C club was founded back in 1998. 4 years after our mother organisation, Constructing Excellence, was also founded, following on from the Latham report, Constructing the Team. We represent all sectors and levels of supply chain in the industry, and we make a conscious effort in having a diverse and equal board. We're working on a number of issues, and we currently looking at big data. The image of the industry will be the next event, sustainability, intelligent client, Bing, and work placement. We've got regional clubs in Yorkshire, Wales, North West, North East, and new clubs have been set up in Kent and the Midlands. Sorry, it's just a long list, I have to read that. We also are going internationally, and if everything is working well now, there should be our friends from New York, Columbia University, watching this tonight. And we would love you to join our movement. So why should you join us? By 2030, there will be over 8 billion people on this planet. like us, even now, they should also be entitled to have universities, schools, houses, and infrastructure. Global construction output is forecast to increase from around $8.5 trillion today to $12 trillion in 2025. We believe that future construction will look nothing like what it looks like today. We'll have to move from a conservative, fragmented, male-dominated industry towards an innovative, accessible, collaborative work environment. Technologies like BIM, 3D printed, augmented reality, and parametric prefabrication can change our industry. But as we kind of felt already tonight, there won't be any change without people driving it. So we think that it's down to us. So if you're also passionate about construction, please do join us. Thank you.